So this topic, that is the hierarchical clustering, that is we move from partitional clustering to hierarchical clustering. Now, as we know that the partitional clustering, that is each sample can only belong to one cluster. But now we are going to talk about the hierarchical clustering. That means we are going to split the clusters into subclusters into more subclusters, and then that means we have different level of the split of the samples. So we need to extract the information before we are going to split the samples. This is the agglomerative hierarchical clustering algorithm. And then so, as I mentioned before, that is in the beginning. And then so we are going to assign one cluster to one sample. Each sample belongs to one cluster. And then each time we are going to find out which two clusters they have the closest distance. And then so now we are going to merge these two clusters. So the number of clusters, if in the beginning we have n samples or n clusters, and then after we merge, and then the number of clusters will become n minus 1. And then we repeat this process. Pick those two clusters. They are closest to each other. Group them, and then n minus 1 cluster will become n minus 2 cluster, so and so. Yeah. So this is the overall pseudocode to do this. Yeah. Before I explain this pseudocode, I'm going to I'm going to define how do we say the clusters. They are nearest. That means when we have two clusters, di and dj, and then how do we measure the distance? Yeah. Okay. Previously, we used the Euclidean distance, but now when we talk about the clusters, and then so we are going to expand the idea a little bit further. So assume that we have cluster 1, cluster 2, and then so we would like to measure the similarity. We have 4 options. The first one, we call this is the D-mean or the single link clusters. Single link clustering. For example, we have many points right here. So this is cluster 1. So this is, or we call this is D1, and then cluster 2, that is, we also have 2 points instead of 4. So single link clusters. Here, it means that we are going to find the distance between I and j. X, that is from cluster 1. This is from cluster 1. And then this is from cluster 2. Find the minimum distance. It means that we are going to find the distance between all the samples. Say we have D1, D2, D3, D4. So find the one with the minimum distance, and then that is the D-mean between Di and Dj. Yeah. So find the minimum. D1, D2, D3, D4. And now, when we consider the complete link clustering, that is the same thing. We are going to find out all the combinations between the samples between two clusters. Now, instead of finding the minimum distance, we are going to find the maximum distance. That is, we are going to find the maximum distance among D1, D2, D3, D4. Okay, and then this value will be this value. Now, DFH, that is, we also call this is the group FH clustering. That means once we have these two clusters, now we have D1, D2, D3, D4. This expression just tells you that we are going to do D1 plus D2 plus D3 plus D4 divided by 2 times 2. The first 2, that is Ni, the number of samples in D1, Ni, that is N1, that is 2, and J, the number of sample in the Jth clusters. So in N2, the number of cluster, that is 2. So this is N1, this is N2. Just find out the FH distance in these two clusters. The next one, D-mean. instead of using the samples itself, we are going to use the cluster centers. For example, we have x1, x2, x3 in D1 right here. We are going to find out the center M1. M1, that is x1 plus x2 plus x3 divided by 3, because we have 3 samples right here. The same for the next clusters, D2. x4, x5, x6. This is M2, M2, that is x3 plus x4 plus x4, 5, 6 divided by 3. So now once we find out the cluster centers, and then we just find out the distance, the difference between M1 and M2, because if we have more than 2 clusters, and then we just find out the centers, find out all the combinations. This is M1 minus M2, this is M1, this is M3, this is M2, this is M1 minus M2, the distance. This is M2 minus M3, the distance. Pick the one with we are going we do not need to have 3 clusters. We just find out the distance between these 2 clusters, M1 minus M2. That is the distance, D mean, yeah? Okay. And now the agglomerative hierarchical clustering, that is, as we know that we start from the first level, that is each sample belongs to one cluster. So we have x1 to x8, for example. So each of them is one single cluster. In level 2, each time we are going to group 2 clusters into one according to the distance. That is, we can use any one of them. For example, right here, this is level 2. We group x6 and 7. So graphically, we can represent that using this diagram. In the second level, groups x6 and x7. And then now, take a look at the distance. Again, x2, x3, they are close to each other. Group them in the third level. Now, the number of clusters is reducing. So repeat this process, and then so we can just simply group all of them together. Yeah. So from this diagram, we can see that we have the subclusters within subclusters, and also we can represent that using the textual representation. For example, when you look at this one, x2, x3, use a bracket to indicate that they are in the same subgroup, and then so x1 and this subgroup, we use outer bracket to indicate that x1, 2, 3, they are in the same subgroup in a higher level. Yeah. Okay, so this is the representation. We have 3 ways to represent the hierarchical clustering result. So if we are going to use different metrics right here, which will give you different result. Yeah. So this one, that is, we use the minimum distance. This one is we use the maximum distance. That is the average distance. So that means different distance metrics we are going to use, it will lead to different result. Which one will lead to good result, and then the metric does not tell you about this. Okay, and now I'm going to use this example to demonstrate how do we apply this pseudocode. So we start with the initialization. We start with a data set. This data set, that is what we have used before. We have 6 samples, x1 to x6 in a 2-dimensional space, x with the components x1 and x2. Yeah. So again, x1, x2, that is not just this boldface x1. It means that this is the italic x1, this is the italic x2. So this x1, that is this coordinate, yeah, -1 and 3. So once we have the dataset ready, we are going to initialize the value of C. The value of C, that is the number of clusters we would like to divide this dataset into. So we pick this value to be 3, for example, and then we are going to set up a counter C hat. C hat, that is to indicate the current number of clusters in this current iteration initially, because each sample is assigned to be one single cluster. So n, that is the number of samples, so n, that is 6 in our example, and 6, that is C hat as well, because when we first enter this line, the number of clusters equals the number of samples. Okay, and now that means we have cluster 1, that is x1, cluster 2, that is x2, so and so up to cluster 6. Yeah, so that is, we have 6 clusters indicated by the green circle. Now what we are going to do is find out the nearest clusters. In this example, I used the group FH cluster, yeah, group FH cluster distance, and then so we are going to find out the distance between groups. This one with this one with another samples. We have to find out all the combinations. Actually, we have a distance right here. Yeah. So this diagram, the green line just shows that the distance between the adjacent clusters. Yeah. So this is sufficient because if the adjacent distance should be shorter than the non-adjacent clusters distance, but anyway, we can find out all the combinations, the distance of all the combinations between clusters. Now right here we are going to pick the one which gives us the nearest distance, and then so we just find out that this is the nearest distance. So we are going to merge these two samples. This one 0, 1, that is x3. This one 1, 2, that is x2. So we are going to merge this is x2. Merge x2 with x3. Yeah. So now in the next line we are going to merge x2 with x3. Now the number of clusters is reduced from 6 to 5. C hat indicate that now we have 5 clusters. Okay. Because C does not equal to C hat, because we want to divide the dataset into 3 clusters. Now we have 5, and then so we go back to the top and then update C hat. C hat, that is, it becomes 4, because when we are going to go through this line, and then the number of clusters will be reduced from 5 to 4. Find the nearest distance, and then we do the same thing. The distance, find out the group FH distance, yeah, and then so we come up with this value, this value, this value, the adjacent distance, and then so we can also find out all the combinations as well. But anyway, we just find out that this distance is the smallest, yeah. So this is the sample x1, this is sample x2, x3. So we are going to group x1, 2, 3 together by merging them into one cluster. Okay, so after merging, we have 4 clusters in this diagram. Yeah, D1, the first cluster, that is x1, 2, 3. D4, that is just one single point. 5 and 6, we have another 2 single points as well. Now, the number of clusters, that is 4. It is not 3, so we go back to the top. And then that is the last step, because this step will merge another 2 clusters, and then the number of clusters will be reduced to 3. So update C hat, now it becomes 3, and then find the distance. So we just find out that the distance right here, that is the smallest. So we are going to group these 2 points. these 2 points, this 3, 2, that is x6. This is x6, and then this point, that is 4, 0, that is x4. So this is x4 and x6. We are going to group them together when we execute this line. Yeah. So now we come up with 3 clusters right here. The first clusters, that is, we have x1, 2, 3, and then the next cluster, that is x4, x6, and then the next clusters, that is x5. We have 3 clusters. So if you would like to reduce further of the clusters, you just repeat this process.